Hey, hello everyone. How are you doing? It's time to welcome you to the module 2 of 40 days of JavaScript, and we are going to get started with our 8th day. Before we get started with the 8th day, let me just give a glimpse like what exactly module 2 is going to be about. In module 2, we are going to get a deep dive into more about understanding on functions and of course about objects. So we are going to get started today with this execution context and the call stack. There's some amount of call stack we have already understood in the last video when we were discussing about function. We are going to get deeper, connecting what execution context is and then how it impact call stack. This is what is a starting point of how JavaScript runs your code. Later, when you go to the asynchronous JavaScript module, there we are also connecting this how JavaScript runs your code using execution context and call stack along with event loop and other queues. So this particular session is pretty important for you if you want to understand JavaScript from its very fundamental and the background perspective. Then we are going to get into scope and hoisting, closure, understanding of this keyword, talking about the string methods, then object, arrays, and that's how with the mini project we are going to end this particular module. So there are lots coming over here. Let's follow the flow and let's continue the learning. Let's learn JavaScript fundamentally like never before. Execution context is the most fundamental part of JavaScript programming language. As we are going to take an in-depth dive into this concept to find out that it is not only fundamental but also very straightforward topic to understand. In many cases, the concept of execution context has been projected as an advanced JavaScript concept, both from the understanding and the complexity point of view. But in actuality, even though it may sound a little bit complex, but it is pretty easy to understand. Very often, you will find developers misunderstanding the concepts like hoisting, scoping, scope chain, closure, event loop. It is only because they don't have the proper understanding of the execution context. That's what we are going to demystify and we're going to learn with a lot of examples and visualizations. When you pick up a programming language to learn, you will find the programming language is full of heavy jargons. That's a bit difficult to kind of understand and comprehend. Sometimes those could be discouraging as well. The underlying concepts behind those heavy jargon or the heavy words are usually very straightforward to grasp. It's just that you need to understand the inner meaning of them. I hope you remember this diagram, right? Few days back, we spoke about tokenizing, we spoke about parsing, we spoke about generating abstract syntax tree, and we spoke about generating the machine code from it, right? So there also you encounter some of the terms like parser, which is also called as a syntax parser that parse your code line by line, understand how it feeds the grammar of the language, and it breaks the things into different kind of tokens, form an abstract syntax tree format, and then it get the final executable machine code. That's how the whole process was. Today I'm going to introduce you to another terminology before we get into execution context. Is called lexical environment. What is a lexical environment? The word lexical means related to something. Lexical environment means how and where your code is physically placed. Let's take this example that you are seeing on the screen, right? You have a function called sayname. Inside that function there is a variable called name, and then there is a console.log, and after some time we are invoking or we are calling this particular function, means we are executing this function. Before the function name and the above there are some amount of code, assume that, and after we executing the same name there are some amount of code below as well. Now if you have to think about lexical environment over here and how things are lexically placed, this is how you will be thinking. The variable name equals to some name, is lexically inside the function sayname. So inside the function sayname, this particular variable name is lexically placed. Now it is important to note your program doesn't run as is by JavaScript. It has to be translated into the machine understandable language. The stage for doing that, the tokenizing, parsing, creating the tree, all that we understood so far. Now for that to happen, it has to adhere your programming's grammar. What is grammar? When we speak, let's say we are speaking in English, we follow certain rules of the language, isn't it? That's the grammar of the language. Similarly, when you are writing program, you have to follow certain rules for that particular program. Now JavaScript has to check whether you are following those rules or not. So whenever something lexically placed somewhere, it has to be done in such a way that it is ultimately following your programming's rule. Now, lexically placing something somewhere is one thing. For example, this variable name is lexically placed inside this function. This function is lexically placed inside this file from the line number 6 till the line number 9, but JavaScript has to map and know what is exactly sitting and whether this is sitting following the grammar of the particular language correctly and meaningfully, so that it sounds valid. Otherwise you are going to get the error saying that this particular thing is not declared correctly, or it might result into some kind of runtime error as well. So this is what is lexically environment, guys. Lexically environment means where your code is physically placed or physically sitting, so that JavaScript as a language can look into the lexically placement of that your code pieces and make sure that finally it adheres to the grammar of the language, so that it passes through and able to execute your code. Then how does execution context, this particular topic, is related to this lexical environment at all? Execution context means the code that is currently running and everything surrounding to that is helping to run it. In the phrase execution context, if you just focus on the word called context, what does context mean? Context means a set of circumstances or the fact that helps running certain events or taking care of certain situation. That's what is context is. Context give you more information about an event or a situation. Similarly, execution context is going to give you the more information about the current code that JavaScript is running and everything surround to that helps running this. That's how you define your execution context. Now in your code there might be many lexical environment. For example, this is one lexical environment because there is a function. Inside the function there is a variable that is got declared. Outside of the function there could be something that might be used inside this function, or this particular function may be using something that is declared outside of this function. So there could be various lexical environment that is possible inside your JavaScript file, but the code that is currently running, that is what is being managed by execution context. And to manage this execution context, JavaScript uses couple of ways of handling your code, or couple of phases in terms of handling your code. And that's why we are going to take that deep dive to understand when JavaScript gets a piece of code in your lexical environment and going to run that as part of execution context, what are the different phases that JavaScript actually execute your code and what exactly happened. Whenever JavaScript code first runs, it creates something called a global execution context. Global execution context. We also call it as GEC. Even if you don't have a single line of code in your JavaScript file, but you load the JavaScript file into the JavaScript environment, a global execution context will be created. What does this word global mean here? For now, take it in this way that global means anything and everything that is outside of a function. You guys know what function is by now. So anything, everything that is outside of a function, let's call it as global. I just now said that even if there is no single line of code in your JavaScript file, still the global execution context will be created. But when a global execution context is created, what exactly JavaScript doing? What exactly it is creating? So I have a file here, index.js file, doesn't have anything, a single line of code. Now if I go to index.html file, which has loaded index.js file over here, and if I just open it up with my live server, it is blank. Of course, there is nothing. If I go to console, again, there is nothing. But JavaScript has created two things here for me. This is what you need to understand. If you are running your JavaScript on browser, even if you don't have a single line of code, JavaScript has created something called window for you, which is a global object in JavaScript. And if you just expand and see it, it has plenty of properties and methods, this window object. For example, few methods that we have already used, like alert, prompt, like the inner height. There are a lot such things that are related to your browser, and the feature and the functionalities that are related to your browser are available inside the window object. Apart from window object, you will find one more thing got created for you in the global execution context, the first phase of execution context, that is called a very special keyword called this. We will have a detailed session in understanding the this keyword, but this is the start. That this particular keyword is given by JavaScript to you in the global execution context of your execution context phases. So here, apart from window, you can also get something called this. But the point to note, the value of this is also the window object. Please remember this. This is pretty important, and this is where people get very confused with JavaScript. JavaScript gives you a window object, we have seen, but it also gives something called this, a keyword, and when we extract out the value of it, we find that the value is also again window object. Can we check if this keyword's value and the actual window object is same or different? Oh, they are same, because it's returning true using the strict equality operator. That means they are of same type and they are actually similar. What does it mean? As both are objects, not primitive value, they are non-primitive value. That means they are not equated by their value alone. Rather, they are the same thing, that is pointing to the same memory address, the this and the window in this case. That's why it is returning true. So we understood that in the global execution context, these two things happen. One is this keyword creation and getting the window object. This particular phase of global execution context is known as the creation phase. Please note it down. This particular phase where we found that a window object has been created, and then this keyword has been created, and we also found that window object is referencing to the same memory location as of the this keyword. But that's not all. There are more things to happen. So far we have not added anything in our JavaScript file. Let's go back to our index.js file and add this code. What we have done, now we have declared a variable called name, added a value called Tom, then created a function called sayname, and here with console.log we are printing this dot name. Before, the file didn't have any code, but now this file has some code. Now if JavaScript is going to execute the lines of code that are there in this file, JavaScript has to create something called execution context. We understood that. Currently, whatever JavaScript is running, JavaScript will be creating something called execution context. Now we already know that in creation phase, this window object, this keyword has got created. But now we have made it a little more complex by having this particular code. And we want to check further that what happened in the creation phase with this particular code. So let's see that. If your JavaScript code has variables and function, the creation phase is going to allocate memory for your variables and the functions. So in this particular code, we have a variable called name and we have a function called sayname. So it will allocate memory for variable name and function sayname. Excellent. And the last thing that will happen now to this variable and the function is, if there is a variable, the variable get initialized with a special thing called undefined. So name will be initialized by undefined. What does undefined means? Undefined means something just got declared or created but no explicit value assigned to it. So in the creation phase, it will just create this particular variable name in memory, but there is no value assigned to it. That's why it will be initialized with something called undefined. But for functions, the function body will be placed directly into memory. This particular phenomena where the name will be initialized with undefined initially in the global execution phase, or the function will be placed directly into the memory, will also influence a concept in JavaScript called hoisting that we'll get into detail in the coming video. But for now, let's remember that global execution context creation phase, this 1 to 6, all these steps will happen. Okay. Now, along with global execution phase, the execution context has another great phase which is called execution phase. Now, the execution phase is the place where the actual code execution starts. In the creation phase, all the memory creation stuff, all the basic initialization stuff, everything is done. But in the execution phase where JavaScript is actually going to execute your code. Now, for the example, this particular example over here, what is going to do? It has already created a memory location for name and initialized with undefined over here, right? But now in the execution phase, it will assign the value, a string Tom, to the variable name. That's the first thing it's going to do. And is there anything else it's going to do? Is it going to call this sayname function? Closely look, it is not. Why? Why? Because in our code, what we have done, we have declared a variable, given it a value. We have declared a function, but we have never invoked a function. So if we have not invoked this function in the execution phase, there is nothing to execute for the function in our code. That means in this phase of global execution context, JavaScript is not going to do anything further. That's why if I am running this particular code, I am not going to get anything on the console.log as an output because I have not called this function at all. Had we invoke this sayname or we call this sayname method, in that case, in the execution phase of global execution context, JavaScript would have started executing this sayname function and would have created the second execution context for us, which we will learn now, is called function execution context. A function execution context gets created only when a function is called or invoked. If a function is not called or invoked, a function execution context is not going to get created. It is only the global execution context that is going to get created, which will have two phases called creation phase and the execution phase. In creation phase, all the memory allocation and all these things happen. In the execution phase is the time where line by line JavaScript is going to execute all your code for which it has created all the memory and initialize thing with undefined or stored the function body into the memory. I hope this picture is clear to you about the global execution context. Next, we are going to modify this code a bit and try to understand how the function execution context works. Now, to understand function execution context, let us take this example. Here what is happening? A variable name is declared, a value Tom is assigned. Now there is a Tom function which has a console.log which says this.name runs, and then it invoked the function over here. In the previous example, we were creating the function but we were not calling or invoking it. In this example, we are invoking it. Now what we're going to do, we are going to take this code, pretend that we are JavaScript, and what will happen in the global execution context, that idea you fairly have now. But there is a function execution over here. We're calling this function over here. So whenever there is a function execution come into place, JavaScript creates something called function execution context for that particular function. As many functions JavaScript find to execute, not to define. A function can be defined but never called, so it is never executed. As many functions JavaScript find to execute, that many function execution context will be created. Let's start with a simpler example and understand for this particular code snippet what will happen in GEC global execution context and FEC function execution context. So here is the code. For this code to execute, what JavaScript is going to do, JavaScript first going to create something called a global execution context. The global execution context will always have a creation phase. We know that what is creation phase. In the creation phase, the name, this particular variable will be allocated in the memory and it will be initialized with something called undefined. We have learned that. And along with that, it is also going to find something called a Tom, a method, and this will be allocated in memory, right? These two things are going to happen. Then for the global execution context, the next phase will come, which is called execution phase. In the execution phase, JavaScript will execute things line by line, and it will find this particular thing var name equals to Tom. Name is already allocated in memory and initialized with undefined, but in this time, it is going to allocate the actual value to the name variable. So name will become Tom. And then what it is finding out over here is like Tom is being executed. At this line, it is not going to do anything because Tom is already defined in the creation phase. So for this line, nothing is going to happen in the execution phase. Now JavaScript will continue. Here it is going to find, hey, invoking a function. Awesome. So invoking a function means I have to now execute the Tom function. The moment a function gets executed, a new execution context will get created, which we'll call a FEC or a function execution context for that particular function which has been executed. Here, which function is getting executed? It is for the function called Tom. For this Tom function, this particular thing will be created, the function execution context. Now, what is function execution context? Function execution context, like global execution context, also will have two phases. One is called creation phase and then another is called execution phase. Just like global execution context, in the creation phase of a function execution context, it will see whether there is a variable, a local variable in a function or not. If there is a local variable inside a function or in the function parameter, it is going to allocate memory for that and initialize with undefined. Just the same thing what happened in the GEC, same thing happened in the FEC, but only for that particular function for which the execution context has been created. Now, if I look into the Tom function as JavaScript, I won't find there is any variable because I have not created any variable inside it. I kept this particular example very simple for you to understand. I'm going to get into the complexity very soon. So it means that in creation phase, there is nothing that it has to do because there is nothing, no variable, nothing. Then it will pass to execution phase. Coming to execution phase, what it will find that inside the function, do I have anything to execute? Oh, yes. In the execution phase, I am seeing there is a method called log from the console object that I have to execute. So it found another function called log to execute inside the Tom function. So if it has found another function to execute, that means now it is going to create another FEC, which is the function execution context, but this time it is going to do it for log from console. Now, as log is a function, for log function, as usual, again, there will be a creation phase where inside the log function, if there is a variable, that will be memory will be created for that, that will be initialized with undefined. If there are any other inner function, a memory will be allocated for this function. If there is nothing exactly going to happen in the creation phase, it will straightaway is going to go to the execution phase, and whatever the code inside the log to execute, that will be executed. Now, for this simple thing, you have seen that how JavaScript is splitting things into different kind of phases and then execute this thing. Now, for the simplicity's sake, if I am going to put boundaries around all these things, so first thing happened is a global execution context got created. After global execution context creation phase, when it came to the execution phase of the global execution context, this particular phase, it found that, hey, there is a function. So I have to find an execution context for this guy, Tom. And again, I ran through the creation, and again, I found there is another function called log that I have to execute. So I have to create another function execution context for executing the function log, which is inside the console. And for each of the execution context, I had a creation phase, I had an execution phase, a creation phase, execution phase. Here also a creation phase, execution phase. So though a very simple code to execute, but this many things are happening. Now let's take back and understand how JavaScript must be managing all these execution context and these phases within it. Here, I have just one function. Inside that I have done console.log, but JavaScript allow me to call a function inside a function, and that function might have another function call. That function might have another function call. A function can be passed as a parameter to another function. So for each of this execution, there will be definitely creation phase, execution phase. How JavaScript must be managing all this thing internally. That is where the concept of call stack that I introduced in the previous videos. And now we are going to take an example, a little more complex example. Please pay great attention to this, and I'm sure that you're going to learn a lot of things from this. And then we will try to visualize that how the execution context and the phases getting created from that particular code and how it's get mapped to call stack, and not only that, even in the memory that JavaScript manages and maintain. And that is where we'll also get introduced to concept of a garbage collection, the word that we would have heard, not in depth, but at a high level, because we have a separate session on garbage collection in the advanced topic or the advanced module. All right, so let's get started with how call stack is going to manage these things, this execution context and its phases. Now, to make things a bit complex, I have these 18 lines of code. Let's go through this code once very quick, and then we'll understand as JavaScript, how are you going to execute this code and how call stack will take care of GEC, FEC and their phases. I have a console.log at the top. Then there is a variable got declared and a value got assigned. Then there is a function called test me. Inside this function test me, there is a console.log, there is another variable, then there is another variable. In this case, there is a number 10 that got assigned as a value, and here there is an object that got assigned as a value. Why it is object? Because there is a key value pair, and within this curly braces is an object. And then there is another function over here which is having a bunch of console.log, and this function test again gets executed immediately. And then there is another console.log, and then the test me function gets over and we execute test me, and finally there is another console.log. So this is what is our JavaScript code is about. Now let's go ahead and take this code and try to create the different execution context. Please pay attention to this because I have given you a task where you have to complete something similar. All right. So here, what do you see? We will first try to locate what is happening in the global execution context. So in global execution context, this particular variable will be created in its creation phase. This particular function whose body will go to the memory, the variable A's memory will be created and it will be initialized with undefined. I'm leaving out this console.log for now. Okay, so this is what will happen in the global execution context creation phase. So in the global execution context execution phase, when JavaScript start executing line by line, it will say variable A has been created in the memory already. Excellent. And it is undefined. So now let's assign the value 5 to it. Great. There is nothing to be done in this pink line for sure because it is already been taken care in the creation phase. But here what I see, there is something called test me. As I say test me in the global execution context execution phase, that means I am going to now execute something called test me. And the moment I'm going to execute test me, that means for test me, our function execution context will be created. So for test me, now it will create a function execution context. Now in the function execution context creation phase, it will see, is there a variable inside this function? I have to create a memory for it. There is not only one, there are two variables. One is B, another is user. So it will create the memory for B, it will create the memory for user, but based on whether it's a primitive value or non-primitive value, it will depend where exactly this memory has been created, whether it's in stack or it's in heap. We are going to see that in a moment, but you guys know about the primitive, non-primitive already, that we have learned in the previous lessons. Now the memory for this B, memory for this user will be created and it will be initialized with undefined. That's the logic. Then it will find, oh, there is another function called test again. Great. So I have to put this into the memory. So that also will happen in the creation phase of this particular function execution context. Now the execution phase of this particular function execution context will start, where it will start executing things inside this function. Executing means B and user is already placed in the memory. They are initialized with undefined. Let's see whether there is a value assignment for them. If so, let's assign those value. Okay, so there's a 10 that's get assigned. There is an object reference that is assigned. There is nothing to be done over here because this has already been taken care in the creation phase, this particular function body already in the memory. But in this line is finding, wow, there is another function that is getting executed. The moment it finds there is another function that's getting executed, it means it has to execute this function, and for that it has to create a function execution context again for this function alone. And that is where now a function execution context again will be created for this function. So function execution context for this function, when it gets created, again it will run two phases. One is creation phase, one is execution phase. Creation phase will see whether there is a variable, there is a function that is getting declared, nothing as such. I'm saying that just ignore console.log for now. Then it will go to the execution phase where, okay, if there is a variable, there is a function, if so, then execute and then come out. So now if you see, again, doing a quick recap, when there was a global execution context execution phase, it first hit test me over here. And the moment it hit test me, it went inside test me. In the execution phase of test me, it hit test again here. The moment it found test again, it went inside it. So when it found test me, it didn't go ahead and execute this particular console.log that was there below test me. When it found test again, it didn't go ahead and execute this console.log, it went inside test again. So whenever there is a function execution happen, the function execution gets started immediately. It will go inside the function, start executing up everything about it, and the next line of the function execution won't be executed until the function execution completely takes place. Okay, so this is what you understand. Now, just like before, if I just whatever I told, I explained, if I write it like the chart GEC, FEC, which will be much more clear for you, right? Let me do that. So first, the global execution context. In the global execution context, there is a creation phase. I'm writing it as CP, okay, as a shortcut. What will happen in CP? In CP, the variable A gets created in the memory and initialized with undefined. Okay, this is done. I'm teaching this because you have to do the task so that you can get better doing it. Test me, this particular function gets in memory. So far so good. That's the creation phase. Next it will get into the execution phase. In execution phase, what will happen? The A is already get created, but now value will be assigned. Okay, and then it will find that I am executing test me over here. So now the test me, this particular function will execute. The moment text me get executed, function execution context for test me will be created. This will also have two phases. One is the creation phase, another is of course the execution phase. What will happen into the creation phase of test me? This is the test me. It will see if there are any variables. Yes, there are variables, of course. So I have B, so it will be initialized with undefined. I have user, it will be initialized with undefined, and then I have a test again. So for test again, a function body will be in the memory. After that, of course, the execution phase will start. In the execution phase of the test me execution context, what will happen? B and user already created. So that means now B the value will be assigned because it's executing one by one. The user, this particular object will be assigned name, tapas, and all its other attribute. And then it will find something called test again. So here it will find something called test again and say, okay, we have to execute test again. The moment the test again execute part come, so that means a new function execution context for test again gets created. And the new function execution context will have a creation phase and an execution phase. So inside the test again, in the creation phase, there is no variable. So there is nothing is going to happen. And in the execution phase, nothing we are doing with those variable or the function because there is nothing else. I'm just leaving out console.log for now. Then nothing will happen. If you take console.log, definitely in the execution phase, it will find console.log. So just like before, again, it will create another execution context for the log and creates its own CP and EP like this. So as you're seeing it clearly that it's got started from here, has its own creation phase, execution phase, and inside the execution phase, whenever there is a function execution is happening, it is getting into its own creation phase, execution phase. Again, in execution phase, if it find another function to execute, it getting into its creation phase and the execution phase. It almost look like a hierarchy to you, isn't it? Now let's draw the memory structure. This is a big thing. Let's take stack and heap, both the kind of memory that gets used in terms of this variable creation, management of the function, management of the object. And when this GEC, FEC, CP, EP, all these things are getting created or happening, what exactly happening to our memory? Let's understand that. We have now taken the same example just now we have seen, but we are going to understand, or we are very interested to understand, like how JavaScript manages all these executions together. Now to manage this, whether it's a variable, it's a primitive, or it's a non-primitive like function, arrays, objects, JavaScript manages everything in memory in two places or two types of memory. One is called stack, another is called heap. So the one that you are seeing over here is a stack, and I have tried to draw something which I call heap, which is over here, right? Heap is a discrete memory, and that is where we are seeing some discrete memory locations where we'll be putting certain things. And then stack is a data structure which you know it's a LIFO. That means last thing that got inside into the stack, that the first thing is going to come out from the stack. It's a stack of plate, it's a stack of book, all these things are stacked. Now, what happened when you go line by line? Whenever this particular code gets loaded onto your browser, what will be the first thing that happen? The first thing is a global execution context will be created. We have seen that even when you don't have a single line of code, in your JavaScript file, still a global execution context will be created. So the first thing that's going to impact your memory is the global execution context. And as this global execution context is getting created, it is going to do a few things. We know it's going to check that in the global level means outside of function, we have already told. Outside of function, do I have any variables? Then I'll be creating memory for that. I have a variable called a over here. So I'm going to create a memory for a. That means I'm going to keep a is in the stack and I'm going to initialize it with undefined. Excellent. Then I'm going to see, do I have a function? I don't have any more variables over here to create memory, but I have a function. I have a function called test me. And as I have a function test me, I have to allocate memory for it. And for that, what can I do? I can put test me into my memory, but what kind of memory? Function is a non-primitive. Non-primitive doesn't get inside the stack. Non-primitive gets inside the heap. So it means the function body, the definition of the function will be somewhere in the heap memory. Let's assume that in the heap, there is a memory and there is a specified memory location with a memory number XA01, some random number. So what will happen? The test me will be over here. This particular function definition goes over here. Now, as this function definition goes over here, the entire function body in this particular memory location, the memory location can be identified with this particular address. And the record of it will be stored inside the stack in this manner. The function name, which is test me, and the reference of it is XA01. And let's draw a pointer from here to here so that any point at time, if I am bothered about test me, I will get this particular memory address which refer to this location of the memory where the actual definition of test me is stored. So this is the first thing about the GEC, and this is where GEC's creation phase, the memory allocation and the memory management has been taken place. Now, as the creation phase of the global execution context is over, now we'll get into the execution phase. In the execution phase, the value that gets assigned to A is the 5. So here the value gets assigned is 5. Test me already have taken care into the creation phase, so nothing has to happen. But what I'm seeing over here, there's a execution of test me in the global execution context execution phase. The moment a function gets executed, I told none of the code below that will be executed. We discussed about that. But there will be a new execution context of test me will be started. In that also there will be a creation phase and the execution phase. But before that, as there is a new execution context getting started, this particular test me will get into now in the stack. So here we'll be having test me. You're getting the point? First, global execution context was there in the stack. Now we are getting test me in the stack. In the test me, again, it has to go through what? It has to go through its own creation phase and the execution phase. Creation phase, it will have B and user as undefined. Let's create them. So we'll create B as undefined, user as undefined. Then I'm seeing another function, test again, and I'm in the creation phase of test me. So I have to allocate memory for this, isn't it? And this is again a function, so I cannot allocate memory in the stack. I have to throw it somewhere in the heap. So let's create test against over here, the memory for it. Give it a memory address, maybe something called YB01. And then let's create a reference for test again, and it will refer to YB01 and then an arrow towards it. Isn't this great, guys? Are you understanding how call stack is managing the things? We are in the creation phase of test me, and this many things have already happened. Now in the execution phase of test me, B and user should be allocated their value. In the creation phase, they had allocated their memory individually into the stack and the heap. But now we have to allocate what? We have to allocate the value. Now B will be allocated what? The value 10. It is primitive. Excellent. It's in stack. But twist in the tail is user is not a primitive. User is a non-primitive. It has a non-primitive value. So it means that this particular guy named Tapas country India is an object. This cannot be in the stack. So this will be somewhere here. This particular object, let's give this another memory location address. Let's say Z, and this user will have this reference ZB01, and then we'll create a reference to this particular memory address. Good na? Because user is a non-primitive, it's an object. It cannot be, its value cannot be in the stack, just like how we have kept B. It will be in the heap. Instead of having this over here as it is in the heap memory, it will have a specific memory address. That memory address reference will be there in this particular user variable. That's how your objects, arrays, functions are always in the heap memory. Okay, what you get in the stack is just the reference, so that whenever you need it, using this memory reference address, you can go to the actual memory location, get the value of it, and do whatever you want to do with it. Understood? Now we have completed till here. Now again, this test again definition, nothing to be done because it has been taken care already in the creation phase. But we are seeing the test against execution. As we are seeing the test against execution over here, that means another execution context will be created for test again. And this particular code is not going to get executed. So previously it had got halted here, came inside it, executed all this, again halted here, didn't execute it. Now it will go inside this test again. For that purpose, we will be creating now test against creation phase and execution phase. That's when test again got inside the stack. In the previous day, I have taught you, when I have taught you function, how the call stack works. Things were going inside the call stack. That's what you learned. You have also have done task. Now we are going much deeper in each of this execution context, how each of these phases have been handled in the memory level. That's the great part of it. Now in the test again, we'll go inside the creation phase. There is really nothing much to do. Execution phase, there is nothing much to do. I'm not talking about this console.log for a moment. So there is no variable inside it, no actual function is inside it. So there is nothing much to do. So far, so good. You know how the things got inside the stack. But there is one more thing that we need to understand, how things are coming out of the stack and what impact it has on the stack and the heap memory. Let's learn that. One vital point to keep in mind, that once the function execution is done, that means the execution phase of a function is over, that particular function will come out of the stack. So once test against both the phase CP and execution phase both are over, this particular test again is going to go out of this particular stack. So I'll remove it. As it is gone out of the stack, you remember inside test me, when it went inside test again, the execution started for test again. Nothing actually got executed below the test again function, right? As now test again is out of the stack, as its execution is over, it will resume the execution of test me from here. That means this particular console.log now will be executed, and as there is nothing after this for the test me function, so test me's execution also will be done. As test me's execution will be done, everything that you have inside the stack will be cleared up. So that means this is no more required. Test me is coming out of the stack. But hold on, don't you see something really odd over here? You had two things pointed to memory location, over here, over here. The thing that was pointing to memory location is now out of the stack. Then do you really need to maintain these things in the memory? Because nobody is pointing to it, right? Nobody is referring to it. So it's a pure wastage if you're keeping inside the memory but not really utilizing it. That's where the garbage collection come into picture. We'll get into the garbage collection in details in the advanced section, but now to get a peek into it, this is where garbage collection come into picture, wherein every cycle is going to see, do I have a memory which is been occupied by something that is not referred from anywhere? Yes, at this time I have at least two pieces. One is this, one is this, that is not been referred by anywhere, but it has something in the memory. All right, as a garbage collector, let's remove it. All right, as a garbage collector, let's make it empty. And there is no one is actually pointing to this. So now we have two memory locations that we have freed up. This might be reused at a later point in time if something need to be stored. So test me's execution is over, test me came out. Now test me when it went inside, it was from this particular point. So this is where it was halted. And if you now notice, this console.log was inside the GEC. So we came back to GEC again because we came out of test me. Now in GEC, this particular console.log will be executed. There is nothing more to execute. So everything that was there in the stack, that gets cleaned up. As it is getting cleaned up, and here also there was something that was pointing to memory before, which is no more required. So of course this gets cleaned up by garbage collector. This reference is no more required. All right. So then stack become empty. So now stack is empty. Your heap, there is nothing is there in the memory. Everything is cleaned up because all the execution is done. So this is how, guys, stack, heap, your function execution, global execution context, your variable creation, function creation, object storing. With one example, we have learned everything together. Now is the time that you take a task. But before that, I want to let you know, guys, that whatever we have learned over here, this particular theory will be immensely useful tomorrow in the next session to understand hoisting and scope. It will be immensely useful to understand closure. It will be immensely useful to understand this keyword in depth, and along with event loop, along with how web APIs work, along with how task queue, micro queue, macro queue, all this thing for promises and the asynchronous programming works together. You have to print it inside your brain if you want to get deeper with it. If you have any confusion, rewind last 5 to 7 minutes, watch it again, and straight away, let's do the task. It's time for task, guys, and some serious task. So again, you come to task.md file under day 08. You will find this task where you will find this program. I have written a program. There are a bunch of variables, again, bunch of functions. Here, the twist is like one function calling another function and returning from here. So what you have to do, you have to create the GEC, FEC with CP and EP flow. You are going to create a flow like this. Like, what is GEC? What is happening in global execution context, CP, EP, and again in the FEC, how it is getting created, CP, EP, what is happening. That's your first task. So keep your code at the left side, create this flow at the right side. Second task, create the stack and heap flow. What does it mean? You are going to create this particular chart, like how every time things are coming inside, what it is referencing, all these things, whatever you have learned using the stack and heap, all these pointers you are going to take, you are going to create, and you are going to take screenshot of each of those stages. Last, you are going to create a stack diagram. What is a stack diagram? For example, first we have seen that global execution context was coming here, then we found that test me came here, then we found test again came here, then test again went off, then test me went off, then global execution context went off. So that means what is happening to your stack, that each phase diagram we want. I have drawn it for the example that I have taken. It looks like this. At the initially stack was empty, and then we got GEC, then GEC and test me, then GEC, test me, test again, then test again went off, only test me and GEC was there, then GEC only was there, then finally stack got empty again. This is also you need to draw and take a screenshot. After taking all the screenshot, you are going to create a readme file, putting all the screenshot and explaining what is the screenshot for, and share that readme file link publicly on Discord. That's when your task gets over. The Discord link is in the description of this video. Please join, come to 40 days of JavaScript over here. All your task link you can post how everyone is posting over here. If you have further queries, if you want to discuss further, please come and post on general, and then we can discuss it further. You are seeing that community is already discussing with me or without me. Please join this. All the source code you can find in tapaScript GitHub organization. Very recently, we have crossed 300 followers. So if you're not following us here, please follow it. And then you can go to repository. You can find 40 days of JavaScript. All the code will be listed in the day fashion over here. If you like the work, don't forget to start this repo. With that, we are done with today's session. The day 08 is over. I hope you liked it. And if it was of any use to you, please show your love with like, comments, and please share about 40 days of JavaScript. This has always been a request from my side to you. And don't forget to subscribe. That gives a tremendous support to me. Thank you very much. Coming back soon with day 09, where we're going to explore hoisting and scope. Stay well, keep learning.